G'day, this is Shane Curry and this is a presentation of my intrusion alarm system. This is my dog, his name is Loki, he's a pup. What this intrusion alarm system is, it's a prototype I'm working on at the moment, which is basically just simply designed to detect if anyone's trying to hack into your computer server. So set up an alarm system if someone's trying to hack you on your computer server, and it also counts how many times someone's tried to hack you. So basically with this system here, I purchased a bunch of module devices from JCar. For your Americans, that's your Radio Shack. And these module devices are going to serve several functions. So what I've got over here is I've got a LED clock. This LED clock is basically just going to count how many times someone's trying to hack your server. I also got a buzzer here. This buzzer is going to set off an alert when there's a hack in progress. And also trigger a red light. I also decided to incorporate ultrasonic frequency detection and motion detection, so I'll be able to detect if there's a human present by the device, and it'll detect how far the human is away from the device and if the human is moving. So without further ado, I'm just going to give you a quick presentation of the features of the device. Now I haven't developed a script yet. I do have a previous script which I have developed before in a previous version of my IAS, which does actually monitor your network port activity, and it uses access control lists with IP addresses, and if an IP address is on the blacklist, it will, well, if an IP address is not on the whitelist, it will set off the alarm. However, with this actual system at the moment, what I'm doing is I'm just testing the current functionality of the devices. So I'm gonna, without further ado, I'm gonna show you that now. So I've developed this several programs via ChatGPT-4, which helped me build the frameworks with a Python scripting language. I just set the parameters myself. So first I'm gonna show you the buzzer. So this program is gonna set off the buzzer. So I'm just going to run the program now. I'm going to set the frequency for say 160. Actually, I'll set it for 86 megahertz. This does have a built-in fail-safe as well, where I don't want it to exceed 150 megahertz, as it's just a small speaker. I don't want to blow the speaker. So I'm going to set this for 86 megahertz, and this is going to serve as the alarm system, which will audibly alert the system administrator that there's a hack in progress. Okay, so that module works. So what I'm going to do now is I'm going to test the ultrasonic. The ultrasonic detects how far, it detects human presence from the device, which is this little device here. So it will send out an ultra frequency wave, and the ultra frequency wave would bounce off objects and would turn back to the ultrasonic frequency detector, and it measures distance in layman's terms. So I'm going to run this program now. So I'm going to set it as automatic test. So as you can see, it's now measuring a distance of roughly around, I'll say on around average around 60 to 80 centimeters from the device. But if I stick my hand in front of the device, it's now detecting I'm quite close to the device, and it's saying about, my hand is about 9.74 centimeters away, so it's roughly around 9-8 centimeters away from the actual device. So I'm going to stop that program here. So that will be great for, say, if you want a robot to detect if there's a human sitting at the desk, and you want the robot to say, "Hey human, your network's been hacked." So, pay attention, and add that IP address into a, blacklist. So now I'm going to test the actual LED clock at the moment. The LED clock. So this is just a basic script. It just basically counts down from 10 to 0 on the LED clock. What I do want to include in this LED clock is basically a counter which counts how many times an unauthorized IP address try to connect to your network via a remote access port lock 3389. So I'm going to start this countdown now. And once I hit enter, it counts down from 10 to 0. So I'll wait for that to finish. And I'm just going to exit the program, because you do need to clean up the GPIO pins with Raspberry Pi devices. That is very important. You always need this program to actually clean up the GPIO pin. So next I'm going to show you the motion detection. This is a motion detection script. I'm going to run this program. I'm going to enter 1 to monitor it for movement. This is the motion detection here. So if I wave my hand in front of this little motion detection, it's going to detect that motion. So I'm waving my hand at the moment. There's a timer, so basically there's these little sensitivity timers on the actual motion detection device that controls the sensitivity of the actual motion detector. It's a cheap device though, so I can always get a better one. Okay, so that shows that program now, and then lastly I'll just show you the LED light. So this is just a program that turns off and on the LED light. So I'm just going to turn on the LED light by entering 1, and this little light here will turn on. So this little light here, I've got it connected to a little resistor. Basically what that does is that this little resistor here resists the current, because I don't want to blow the light. You've got your positive and your negative terminals here, so simple circuitry with that. So what this device does, it runs off a Raspberry Pi microcontroller, which I've got connected to a cooling system here as well. It's 8 GB worth of RAM. This is connected to the GPIO pins of the Raspberry Pi system. You've got different types of GPIO pins, such as your SDA and SCL GPIO pins. I'm not going to go into further detail about that. It runs basically off pins which produce 5 volt of current, or 5 voltage, or 3.3 voltage. This system's all connected to a Duratec GPIO shield, which is this shield here. This allows me to connect multiple devices to the Raspberry Pi. So yes, basically future implementations I want to include onto this device as well. I want to include this little module here. This module here, will basically, I wanted to read how much system memory has been used. So if the system memory has been overloaded, it'll alert you. And I also got this little servo controller here. It's basically like I'll put in its little lights here. It's basically like a gear-based system. It works on gears, rotating gears. I do need to probably buy a motor controller to work this. This way is a little flag and detect you to alert people how your system is someone trying to hack your system. So yeah, that's what I've been doing at the moment. I do want to incorporate OpenAI systems into this as well. I'll be looking at the Llama website. So there's multiple OpenAI systems which are coming out at the moment, and these OpenAI systems will be able to give the robot personality. So if I attach a microphone and a different type of speaker to this device, you'll be able to have a verbal conversation with the robot. So you'll be able to ask the questions when it alerts you, saying, hey, someone's trying to hack your system, and the robot will actually verbally say this to you, and you can ask the robot, how do I prevent that person from hacking the system? And then it'll provide an instruction. It'll be like, okay, just go into your Windows firewall of the server that someone's trying to hack, and just simply block the IP address. So yeah, it's a little pet project of mine. Pretty cool device. Moves things away from the actual screen itself and puts it into a physical device, like a car alarm system, but for your computer. Kind of like a guard dog system. Hey Loki, come over here. He's not listening. Hey Loki. It's like a guard dog system, but for the computer, isn't it? I don't think Loki's really that interested in the intrusion and alarm system. He's got his bone. He's more interested in the bone. Anyway, yeah, I'm going to continue working on this project in my time. I'm a university student, university graduate from Charles Sturt University. And yeah, I find this a little fun project to work. I like working on electronics. I like computers, and I like how the computers can be used to actually program little electronic devices, which sets off a whole bunch of bells and whistles, which I think it's pretty cool. Eventually, I want to turn it into like a robot, which can, probably walk around the house and greet you and alert you if it detected any hackers on your network. Oh, and lastly as well, I want to include another function into the intrusion alarm system. Say if you've got a desk plant and you want to make sure your desk plant is getting enough water, I've got this little device here which I want to connect to it. Basically what this little module does is you stab it into your into the plant soil, and it monitors you know, your soil how moist the soil is. I also got this little device here. I haven't been able to get it working. I think it's because it's missing a microcontroller and needs a second attachment. I can't see any microcontroller connected to it, but it'll be able to monitor external temperature. I also, speaking of temperature, I also want to get another LED clock as well, because I want to monitor CPU temperature. I don't want the CPU going over the throttling zone, especially when I start using these new up-to-date OpenAI systems, which do use a lot of CPU resources. I think now they're bringing out neural processing units like a CPU, but for AI. It's called NPU, but that's a story for another time. But without further digress or whatever, I want to be able to monitor CPU temperature as well, because I don't want the CPU getting too hot over the throttling zone of 50. Anyway, that's my video. I'm going to continue working on this system in my spare time. I do find it quite entertaining to play with all these, you know, little electronics, and eventually I will build my own Johnny 5 type of robots. Yeah, that's right. That would be cool to actually build Johnny 5. Yeah, that would be cool. Anyway, yeah, you have a good one.